All right, so this is Chem 1. We will start the lesson soon. We will first of all have a, we'd like to take in attendance first. This is 900, day 6. This is day 6. So 11:05, 11:45. Yes, that's right. So, 陳偉豪, are you here? 陳偉豪, 趙家明, 趙家明, present? No? Are you here? 趙家明, no. 好，梁建偉，
喺度。
李振傑，李彤，吳征豪 ，Are you here？ 吳征豪，徐家榮，Are you here？ 好，胡嘉龍，
喺度。
岳斌，翁正南，係你Anakin，
喺度。
蔡俊明，
喺度阿 Sir。
係朱潤輝，黎允正，
早晨阿 Sir，我哋又見面啦。
係李健朗，杜少華，not here， just entering， 文希，溫志偉，
喺度。
係余子豪，
喺度阿 Sir。
Yes， 袁天佑。All right, so who haven't have your attendance ticket? 陳偉豪、趙家明。
喺度。
趙家明喺度 ，OK。李振傑 ，Yeah。李彤啊，要啲李彤。I know 李振傑 is here, but 李彤、陳偉豪 ，two of you absent. Who else? 徐家榮。
喺度。
Yeah. Just entered. All right. So we have got this, and we would. I've just sent you the 2 documents for you to do. And today is about industrial chemistry. One is industrial process. The other one is green chem. You may find it in WhatsApp. Just click it and take a look on that and try it. Okay. After 1 minute, and I will start the lesson. And for Lai Wen Sing and Lai Wen Sing, Jing Ho, yeah. Okay, I marked your word. Pong Gao, you're here, right? You want to do the MCs this time? Or last time all those exercises have been given to all of you, right? Have been given, including the green chem, etc. If so, I would give you the MC. All given? Oh no, I forgot. Just wait. Mhm. Okay, first of all, you guys take a look on your exercise and trying to do the second question this time. Harbor process we have just covered last time. Okay, we continue on the second one. Let me see. I did not find the MCs. Why? Where is it? Is it this one? Yes, that's right. Right, so the rest of you may try out the first question. The second question, what I mean is. All right, so first question is about question chapter exercise 45. Let me share the screen. First of all, yes, this is the one. So we start from question 2, the electrolysis of using chloralkali industry. Okay, chloralkali industry. So we have got two industrial process that you need to know. One, do you still remember that two process? Two industrial method. Anyone who can help? Telling the others what are the two industrial process? What are the two? 温志偉, what are the two? You've got two methods for industry. For comparison, we've got to do. What is that? Flowing mercury. Flowing mercury cell. The other one is what cell? Do you know? So this is for you to have a comparison. Membrane. Yes, that's right. So question 2A. You need to get to know that too as a comparison. Remember. Suggest the feedstock use for question 2A. Anyone who can tell? Yes. I just see somebody. Yep. Brian. Yep. What does it mean by Brian? Yes, concentrated sodium chloride solution, or you use the word saturated. Okay, saturated sodium chloride solution. So remember, if you write down the sodium chloride solution, you are going to indicate the concentration as well, the relative concentration, because the higher concentration of sodium chloride will only produce chlorine gas. Okay, so such that you can tell it's chlor and alkaline industry. The left behind product is alkaline, right? So such 3 products form in the electrolysis. As I said before, we have got chlorine gas. Okay, it is in terms of CO2. What else? 3 in sodium hydroxide solution and hydrogen gas. Yes, that's right. Hydrogen gas, H2, and finally it is sodium hydroxide solution. So it is in form of NaOH, AQ. Okay, so it's it's an easier start. So just why chlor-alkali industry stop building new fluorine mercury cell nowadays. So you may think of some bad points of mercury. Okay, 文氣, do you know what's that?文氣, are you here? 文氣. Yes, toxic. So remember, whenever you say the chemical, you need to tell me the chemical as well as the description, toxic. Okay. Any other answer? Okay, can we use this part, hazardous, or you use the word harmful to describe? Is it possible? Is it okay to have that 2 terms? No. No, why not? No, no. These 2 terms, no. Okay? Why not?李正傑, are you here? Why not? I can't be your hazardous harmful. Yes. You think that 2 can be used, right? To describe mercury. Or do you think yes? Okay. How many of think that is a yes? Hazardous harmful can be used to describe mercury. 趙家明, what do you think? Jiu Gaming. No, that 2 cannot be used. Okay, how many of you will think that it can be used? Please put a tick. If no, across. Doing that. Let me know your thoughts. Did you think yes? What else? Who else? Li Hian-Long, you also think yes. Okay? Why not? Why not? Li Tong, you're a bit late today.
Yes, sorry.
Where have you been? You just could you please help answer the current questions? I've just posed it. My question is, the use of the chemicals. It's mercury, right? I just asked for whether or not the description. It's also possible if I change it to hazardous and harmful. What do you think? Can it be used?
應該唔得，係用最嚴重嗰個㗎嘛，係嘛？
最嚴重嗰個 What do you mean by that? Can you elaborate more?
即係譬如嗰啲咩 console 嗰啲有 harmful 有 corrosive，但係佢唔會寫 harmful 上去。
All right. So what do you think to be the hazard warning label to be used on the bottle of mercury? It's toxic? Is hazardous harmful? Is mercury toxic? Is mercury hazardous? Is mercury harmful? What do you think?
三樣都係啊。
三樣都係 but because yeah, but why not I put it as hazardous or harmful?
因為 toxic 包埋 hazardous 同埋 harmful。
Oh, you think that toxic will include hazardous and harmful? Okay, how about the others? I would like to hear from some other viewpoints. Okay, 盧少華。Hi. What do you think about the use of these three terms to describe mercury? Mercury is toxic. Is correct, right? Mercury is hazardous. Is it correct? Mercury is harmful. Is it correct?
Toxic.
Toxic. Only. You can only use toxic to describe mercury. Why not hazardous nor harmful? Why not?
呢個精準啲。
精準啲. What does it mean by 精準啲 in terms of what? In terms of what?
佢啲特性。
特性精準啲. So anyone who have read through this page, lab handbook 睇過未？
睇過計數牌。
咩啊？
睇過三色 fit 呢個 topic 呢本書。
我睇識 fit 嗰度嘅 but this time is not. You need to take a look on this page. It is from the hazard warning. Indeed, we call that a hazard warning label. Okay, so hazard warning label means something it is hazardous. You need to be aware of it, right? So hazard warning label. So hazardous nature, can you see that? So indeed, it comes to the people's sense of the use of terms. It is subject specific or language specific terms. So if you want to talk about hazardous for non-chemistry people, non-chemistry studying people, or with those chemists, they would treat this term different meaning. Can you see that? Because for the hazardous, it mean in general public means something like dangerous, right? And something not too good to the human. A very general term. But for the chemist, for hazardous, that means what? It is also a general term to tell you something it is related to safety hazards, right? While the safety hazards, they would comprises different way to describe. Okay, so whenever we talk about hazard warning label, can you see that hazard warning label? It will tell you what are the potential danger that will bring when you use the chemical. Now, so I would like to show you the different way of classifying the chemicals, which is explosive, oxidizing, flammable. That the top three, what you may find is that they will give a symbol that may cause explosion, burning, and burning, right? Can you see that? But the difference is that explosion is something more serious. If you want to tackle it depends on the nature of chemical, just like old stock of potassium, sodium, which have that, because it has formed some superoxide. Well, superoxide is rather unstable. Ammonium dichromate, 2,4-nitrophenol, all those, they are just explosive. It can cause a risk of explosion if you have a shock or if you have a friction, and they will start the explosion. Can you see that? It is something, a reminder, okay? A reminder to tell you that once you handle this chemical, you need to be safe. Otherwise, without any proper safety precautions, they will lead to an explosion. Can you get my point? So similarly, some other chemicals will have their own property, just like it will catch us fire easily. So if you say so, we will describe the chemical as flammable. Okay, so you may see those flammable substances here. When you compare with oxidizing, it's different, right? Oxidizing means the one which may have a highly exothermic reaction when in contact with easily oxidizable matter, and also they will create some fire. Okay, so that too is a little bit different. So that's why you may see KMNO4 nitrate, corn nitric acid. They are just a very common example. They will tell you it is an oxidizing agent. So that's why we have a clear definition of explosive, oxidizing, and flammable. But of course, in general, they will tell you something about fire, right? But you have a very specific classification of those. Can you get my point? So hazardous is too general to tell, because hazardous can mean something like this, okay? It can be explosive, oxidizing, flammable, carcinogenic, toxic, harmful, corrosive, irritant, etc. So too general. But if you want to talk about harmful, harmful means something else. Harmful, it is a wicked effect of toxic. If you want to take a look on that too, on the right-hand side. Okay, I would like to show you the one on the right-hand side. So toxic, harmful, corrosive, irritant, that can be categorized into two main areas. Toxic, harmful, why would I say in the same area? Because once you breathe in, swallowed, absorb through the skin, they will cause your immediate health effect. That may be cause you some health risk or even death. It is more severe, we call it toxic. It's less severe with a limited health risk, we call it harmful. So mercury belongs to this category. Okay, mercury belongs to toxic, this category, but not harmful. Okay, remember, because they will cause more severe health effect than what you may expect. So if you describe mercury as harmful, you just underrate the health effect. So people who read the term harmful would underestimate the potential danger that may bring to you while you use it. Can you get my point? So do not use harmful to describe mercury. Toxic is toxic, okay? So that you have to tell the several level to reflect the several level of danger, potential danger to the people. Can you get my point? Similarly, it's on the corrosive and irritant, okay? In case some weak, some dilute acid, just spray it onto your hand. You have got the itchy feeling, okay? Can we describe that action irritant or corrosive? So this is another different way to show the extent. If you talk about corn, acid, or alkali, normally we describe it as corrosive because they would give you immediate destroying of your living tissue upon contact. If you touch it with the if you have a first contact with the skin, of course, the skin will be destroyed by those corn acid or corn alkali. How about irritant? Irritant is not that severe. Okay, the effect is not so severe. It just causes some reddening, turn red, or inflammation. So that two, they will show you the difference extent. Can you get my point? Samson, can you get what I mean? Can you get what I mean?
Get it.
So what is the hidden message? If it is toxic, you have to label it as toxic. You never label it as harmful. If you treat the toxic chemicals as harmful, what do the user think of it? They will think of it is less dangerous, right? They'll mistakenly think it is less dangerous, and and the safety sense will be much lower, right? They will, for example, they will handle it more casually. So finally, the health risk is more than what they will come to it. So so remember that three terms, you need to be highly aware of the use of that three terms, but cannot be interchanged. Okay, but cannot be interchanged so casually. Do you understand? So hazardous is too general. Harmful, it is a less severe mode of toxic, so it cannot be used. You got it? Never confuse about that. D, suggest how chloralkali industry produces chlorine bleach. How can we get chlorine bleach? Listen here. Anyone who can call upon Chen Weihou for me? He's absent today. Where are we? He's gone. He was absent in the first few lessons as well. Anyone who can call him back to the lesson? Let's take a look on D part. Take a look. Just how chloralkali industry produces chlorine bleach. How? How? No? Hi, ladies and gentlemen, where are you? If not, Wu Jinghou. Are you here, Wu Jinghou? Not here. Wu Jialun.
Hey.
Yep. How to make chlorine bleach in chloralkali industry.
Chloride ion is preferentially discharged.
Yep.
Chlorine gas.
And then chlorine bleach.
And chlorine bleach is manufactured from chlorine gas.
Yes, and you can directly make it as chlorine bleach, right? How? How can we make chlorine bleach? Only chlorine? Only chlorine can help? It's not just chlorine only, right? You are going to think of, yes, that's right, it is sodium hydroxide. Chlorine plus sodium hydroxide to form chlorine bleach. I need that two ingredients. Equation, please. Equation. Equation. You don't know. So you better memorize this one, especially somebody who forgot this. Yes, to form sodium chloride, sodium hypochlorite, and water. So this is the active ingredient of chlorine bleach, okay? It is sodium hypochlorite. Sodium chloride, it is the byproduct, and water. And remember to put a 2 here. Okay, memorize this term, please. So it is about it comprises about 5 to 6%, okay, by mass of sodium hypochlorite in the chlorine bleach. Most of them they are just water. Sodium hypochlorite is an active ingredient. And during the process, because I also produce sodium chloride, so for somebody who think of testing for the presence of chloride ion, what I mean is I use acidified silver nitrate. White PVD will also be formed. That's because in the chlorine bleach, it would also contain chloride ion. Even though it's a trace amount, we still have chloride ion. Do you understand? So remember, it's different. It's different from hypochlorous acid. In Chem 2 students, we just spend some time on telling the difference between the two, okay? So hypochlorous acid is something like this. It is a dissolving of chlorine in water, but not chlorine in alkaline. If I dissolve chlorine in alkaline, it forms chlorine bleach. But hypochlorous acid means something else, dissolving chlorine in water to form an acidic solution. While for chlorine bleach, it's an alkaline solution. It's different. Do you know it? Do you know the difference between the two? Huh? You know the difference? All right, so E part suggests why it's dangerous to mix chlorine bleach and acidic substances. Now, especially during the recent epidemic, you should heard of this argument, right? People will think that kill germs, use chlorine bleach can help. Kill germs can also be helped by using some acidic substances, right? So why not mixing the two to give a better effect, to give a concerted effect? But the question is telling you it's wrong. It's dangerous. Why so dangerous? Why so dangerous? Yung Zhengnam, why so dangerous? What would happen if I mixed chlorine bleach and acidic substances? Some other things will be formed, of course, right? There may be some chemical reaction. So what is the chemical reactions? Yung Zhengnam, are you here? Yung Zhengnam, yeah. Tell me what happened when I mix chlorine bleach with acidic substance. What will be formed? Yeah, I'll give you a hint. It's a toxic substance. It is chlorine. Remember, please relate the term toxic and chlorine together to tell you how dangerous it is. Okay, how dangerous it is. So you just mentioned the equation, right? Take a look on your equation. Is it do others agree with that equation? Is it the equation? Sodium hypochlorite plus acid plus HCl to form Cl2H2O NaCl. Agree? Agree with that equation? Please give me the equation, balance equation. Choi Junming, are you here? Choi Junming. Choi Junming, not here? If you are not here, I will ask you guys to go to the waiting room to stay for a while. Not here? Yeah. Equation, please. Samson, you should be the one to tell the equation as well. Yeah, OCL minus and then I just heard of OCL minus and then
OCL 負加呢個加
hydrogen ion and then again that this is a second equation in which I will ask you guys to memorize. Besides the production of chlorine bleach, this is the second equation that I need all of you to pay attention to. Hypochlorite exit. How would you get chlorine? I know it's chlorine here, right? But how will you balance the whole thing? So strange, isn't it? Very, very strange. In which the charge cannot be balanced. Do you know why? You miss out something. You miss out one more chemical. What is that? You take a look on the ingredient of a chlorine bleach. Water on the left-hand side or right-hand side? Right-hand side. So what will happen to the left-hand side then? Yes, chloride ion. Okay, we've got 2 here. And while this equation, try to take a look on this. Is it just like the opposite? Can you see that? It seems like the opposite of this equation, but this time in a chlorine bleach as the condition, inside we would not have, it's an alkaline medium, so we will not have HOCl as a molecular form. Instead, we have got hypochlorite ion, chloride ion, and 2 hydrogen ion to form chlorine gas and H2. While that equation is very similar to the dissolution of chlorine in water. Can you see that? This equation is just the reverse of that, but change a little bit. I split the HOCl into hydrogen ion and hypochlorite ion apart, like this. You got it? So you miss out this one, and afterwards, while you balance the whole thing, you may find that, okay, not only the chemicals there, but also the charge can be balanced. Understand? So you better circle that, then memorize this part. Question 3. Any more questions so far? If not, here comes question 3. Answer the following questions about methanol. Suggest one industrial use of methanol. It seems many of you have forgotten the stuff of paper 1. Lý Kỳ Nong, are you here? Yeah. 3A, suggest one industrial use of methanol. So what is the use? M. M means not the answer. Money. Money, are you here? Money. Yes, feedstock of a manufacturer of something. What is that? Just give me your answer. Synthetic polymer. You can. You can. What else? It is, first of all, it is a 1 carbon compound. It is a very good starting material. If you want to talk about primary product, what you mentioned about the polymer is a secondary product, okay? To make what? Starting material to make organic compounds. with larger carbon number. Okay, so that's why you may produce it to get ethane exit, for example, ethane exit. Okay. Of course, if you think of something more primary, you may start from methanol. Methanol, you can go to methanol. Methanol is also possible, right? Methanol. Acetic acid is ethane acid, ether, dimethyl, etc. Right? You may think of methanol as well. Got it? Okay. B. The methanol can be produced by syngas in the presence of these catalysts. List the temperature and the pressure required for this process. The experimental conditions. You still remember that too? Temperature and pressure to produce methanol using syngas. Bookwork, you better search on the book as well if you forgot. 730 atm, is it? Now check the use of, which page do you find it? Do you use nickel oxide catalyst, right? You may use as a steam reforming of methane, a natural gas. To form methane, carbon monoxide. What you just search is just the production of carbon monoxide and hydrogen, but not what I want to find out is for the production of methanol. Take a look at the word methanol. You search it again. That may be the question that next to it. You may find it, or you nearly locate it. Instead of blaming yourself, yes, this is 200 and 300, yes, degrees Celsius. And for the pressure, what is the pressure? About 50 to 100 atm. So, next time remember to indicate the unit, right? Without unit, if the unit is wrong, sorry, no marks. You got it. You may find in the book page 110. Now, for some others, you are going to find out the book, page 110. You may find this answer. C suggests a now advancement of the methanol production technology. Explain why it's considered as an advancement. What advancement does it have? So you may find it on page 111 as well. Can you please use that terms to elaborate? And advancement, right? 2 marks. But advancement, we usually refer to comparing the old method to the new method. So remember, you are going to have a sense of comparison. Sense of comparison. Any points? Any points that you can make? Anyone who can help? No? No? 温小慧. So it is mentioned that you are going to have syngas, right? So what is the raw materials of making syngas?
Methane original.
Methane. You may use methane, right? So if you talk about advancement of the methanol production, methane you may use. Where you will find methane actually?
Fossil fuel.
Fossil fuel, yes, that's right. For example, natural gas. Any alternatives? Any alternatives? If you have thought of, yes, we thought of alternative, it is advancement, conversion of, for example, biomass. You know it, right? The biomass of syngas, okay, to produce and later on to produce the ethanol. So we focus on the raw materials, okay? Biomass versus natural gas, for example. So what is the point of comparison? The conversion, they will use what? Renewable feedstock. Can you get my point? So it is a type of comparison that you may know. Comparison. So versus natural gas, it is non-renewable. All right. What else? I see one student, you just write down to reduce the release of carbon dioxide to the atmosphere. Can you elaborate on more on that? How? How can we reduce? Yes, this is also a point, but you need to tell me how. How to reduce the release of CO2 to the atmosphere? How? You know that carbon dioxide is always treated as a waste, right? So I will just let it go to the atmosphere without any treatment. But this time, you may use this in the fuel gas. Okay, you know that CO2 is in the fuel gas. So the waste gas, okay? So I can use this as the starting material to produce, okay, methanol. Can I use this part? Can you get my point? So it is also an advancement of the methanol production technology, and it would help indirectly. That would help, may help alleviate what? Global warming, right? Because CO2 is one of the greenhouse gas. It is our concern. You may think of some other thing else, right? I just point out 2 points, and you need to give me 1 point only. So remember how to score that 2 marks is to give that point of argument, and we are going to compare the past and the present with a very specific area. Okay. So what is the concept that is underlying? We call that green chemistry. Green chemistry. Okay. So that's why it's our turn to take a look on the green chemistry. Is 46, unit 46. You may click it on the WhatsApp again. Chapter 46, the chapter exercise. Any questions so far? Any questions so far? No. Yes, no, yes, no. If no, if you have got no questions, I will proceed to 46. Okay. Do you see that? I just opened chapter 46. All right. Have you copied those things for chapter 45? Here comes 46. We've got two processes. You are going to ask for the calculations of atom economy in process 1. Atom economy of process 1. Choi Jia-ming, you know how to answer this? Atom economy for process 1. How? I know the answer is percentage, right? How? How to calculate this? How? How come today I just talked to the air, huh? For some others, no response. 陳偉豪
Hello 阿 Sir，
Where were you?
哎呀，真係對唔住，明明起咗身嘅，又瞓翻，唉。
Are you kidding? Are you kidding?
哎呀，而家好想打字嘅，哎呀，
You just slept?
係啊，
Okay. I'll believe it or not. Same. Is it the same fate as 李彤? 李彤, you just slept? So that you were just
喺
late.
度啊，喺度啊。
哦，
唔係，我遲咗啲起身。
So what is the difference? What is the difference? Tell me.
我早佢少少起身。
So don't tell me that in the previous lesson you two also were absent before chemistry. Isn't it?
係啊。
E3 double lesson, you both of you were absent. While in the first lesson, even the
陳
first
偉豪
lesson you were
冇
also
E3 嘅，
absent.
但係我有 E3 啊。
Oh, but you absent. You were absent as well. How about the first lesson?
都
Huh?
係啊。
搞錯啊! It's very bad. Initially, I just want to record this video and then post it to the YouTube, but it's quite difficult for me to do so now. Full of sentiment. The video have full of sentiment, huh?
可以剪下去。
Okay. You have so advanced scientist skills, right? You help a lot in making the video, right? You are so advanced, right? You may help. Samson, that means you may help, right?
冇嘢，下次先啦。
Now, take a look on Choi Jia-ming's answer. 咪係60 over. What is 60? What is 60? 60 means the target molecule because for that you are going to heading for ethane exit, right? The use of atom, right? So this part must be something about ethane exit. It is 60. Yes, that's right. But the stoichiometry is just all those just 1, 1, 1, 1. So no, don't worry. Just add together and you may get the answers. How about the reactant? The reactant, okay? The reactant. How will you put that? Just directly put them down the relative molecular mass. So you may find 46.0 for the reactant side and the oxygen, it is 32.0. So what will be the answer? Yes, that's right. The approach is correct. What is the answer? 76.9. Okay, 76.9. Okay. All right. For those who just fall asleep, I would seriously invite you going back to school, right? to have a face-to-face lesson while I'm delivering the lesson on the notebook. You're going to sit in front of me. 你同人陳偉豪 you will probably be for the first two to be invited, isn't it? 陳偉豪 you just gone away.
應該
Yes.
瞓飯。
真人班 OK 你同真人班 you have been waiting for long, right? Instead of have a video class, this time it is 真人班 including 蔡俊明. Don't laugh at each other, right? You just also have just passed through the hard time. You are once like this. Students think that process 2 is greener than process 1. It keep you awake. Just answer them for me. 李彤. And next one will be 陳偉豪. You too. I should do something to keep you awake. Students think that process 1 is greener than process 2. Suggest 2 reasons. Each of you give 1 reason, please.陳偉豪.
process one 嗰啲 reactants 係non-toxic。
No, it's non-toxic. Process 1 is non-toxic. So how about process 2? You need to give me a sense of comparison.
但係 process two 有 methanol 同埋 carbon monoxide 兩個都係 toxic。
Yes, that's right. You need to give me a comparison. Remember, process 1 use of non-toxic reactant. So you need to indicate both the reactant. You simply just write it again. Just copy this from the equation. And then while you compare with process 2, it is not green because you need to use the toxic reactants. So indicate very clearly that methanol, both methanol and carbon monoxide are toxic. Do you understand? So this is point 1. How about point 2? 陳偉豪
係咪講返佢個 U 係即係都去唔到咁高啊？
What do you mean? Sorry, you say that again?
佢雖然個 atom economy 係76.9%，但係佢個 yield 係去唔到咁高。
All right. So you talk about yield. Any information that you know about the yield, process 1 and process 2, the yield. Do you know that exact figure? Now, first of all, if you know it, if you know the data, you can retrieve it on the sites, you may say, and you can argue. But at that moment, what you will see is just the 2 equations. So how would you tell the one of that will have a higher yield than the other? Do you have enough information for you to judge? So try to put it in another way around, okay? Which means that whenever you are going to argue, you have to argue based on the information given. And there is the second point in which the item has been embedded inside. It depends on you how well you can spot it out. Terence, you don't know?
唔係好諗到。
How about your companion? You should help answer. For those who for the one who have just suggested the first point, I'm sure you can make the second one. 李唐
我都諗緊。
don't pretend that I'm not talking about you. You have to tell. Now take you may now very often if you talk about green chemistry, what area would you say? Now experimental condition, the use of catalyst, the waste, right? The one I mean is the byproduct, the reactant, the use of the reactant being toxic or not. What else? How about the reactant, nature of a reactant? Where you will find the reactant? We call it feedstock. The source. Can you think of the source? Where you can find ethanol, oxygen, methanol, and CO, the source. Would it help? What to compare? Tell me the source.
E-signal 係可以通過嗰啲fertilization 整出嚟嘅，但係C carbon monoxide 或者E-signal 主要係通過一個先 gas which is 係要用到 fossil fuel 係 non-renewable 嗰啲嘢。
Yeah, process 2, methanol, CO, right? All those they are from the non-renewable feedstock, okay? Non-renewable resources. So what is that? You may think of petroleum. If you want to argue the point of renewability, you may do the same by comparing process 1. Process 1, so what is that? We would have CH3CH2OH, ethanol, as well as oxygen. Both, they can be generated from the renewable source. Okay? Why is it so renewable? About O2. O2 is non-depletable, okay? It's from atmosphere and you can get. How about ethanol? Ethanol, it can be from what? Fermentation, right? Fermentation of the plant material, right? Fermentation of glucose, for example. So you may use this as a point to compare the greenness of process 1 and process 2. It seems that most of you have forgotten those. How can we have a quiz this Friday? Don't you know that we have got a quiz on industrial chem for the first 2 chapters? Maybe some of you may argue, Mr. Jin is the later half, right? So you need to spend 1 more week such that you can catch up with all those. Okay, wait and see. This Friday, first 2 chapters of InduChem. Next Friday, there will be the quiz on the later half. Okay, can you hear me? Zhao Zhiming. Right, the possible name for process 2 that is carried out industrially. Process 2. So what is the name of the industrial process? That is direct synthesis of ethanoic acid from methanol. So what is that? What is the process? You search on the book and you can find. What is that? Textbook page where? Tell me where? Green chemistry. Of course, you have to relate back to the green chemistry. Where is it? 133 and 34, right? Yes, that's right. So can you tell me the name? One of them is, because we did not mention about the condition, but it's very general, right? The equation is very general. So you can either answer it as Monsanto process or Capita process. Okay, it's on textbook page 133 to 34. Questions? Now here comes question 2. The methanol can be produced by carbon monoxide via process 3. are produced by carbon dioxide via process 4. The both reactions require catalysts. Explain why both reactions are very slow in the absence of catalysts. Okay. 陳偉豪 A part. So what is that?
咁啊，等陣先啦，睇下先。
點啊？搞搞震你兩隻嘢。你同you should know that you will be the second one to catch up with it and answer. Don't you know that? So what is it?
俾你同答下啦。
唔使咁禮讓啊 Two of you will answer it alternatively. Need more temperature and pressure. Why? You just tell me the facts that in order to do the same, you need to have a high temperature and pressure and high pressure and to speed up the reaction. But the question comes as reverse. How come both reactions are very slow in the absence of catalysts? Very slow. It's because of what? You may think of energy pathway, right? It's not that difficult to tell about the activation energy for the both process are rather high, for example. Yeah. B, process 3 requires this as a catalyst, the pressure and temperature required. Isn't it similar, right? Very similar to what you have seen it in the past exercise, in the previous exercise. Tell me the temperature and pressure again. 老少話你同 OK, you may answer. 你同 tell me. You just open the mind.
係200至300度。
check force check 咗 ，check force 有兩個嘛，2選1。跟住
200 and 300 degrees Celsius and then pressure. 我未醒喎，你兩隻嘢真係醒未啊？你冚自己兩巴先啦。唉，冇聲嘅你哋咩？冇嚟神氣，點搞啊？你真係。C part, explain why process 4 should be carried out in a high pressure but not atmospheric pressure. 老師話 give you a chance to tell instead of laughing the others, right? Laughing at the others. Process 4 should be carried out in a high pressure but not atmospheric pressure. So we will put it in another way around. Why would I would like to increase the pressure in this process? 2 points actually. 2 areas of concern. Yep, tried. Hi, 老師偉。You just turn on the mic but without saying anything.
諗緊。
哦。How about this? If I change process 4 as this, would it help? Would it help? Increase pressure, what will happen? Yes, it will produce higher yield. Why? Why? Yes, higher yield, higher rate. Very good. The concern is about equilibrium as well as rate. Very good,梁志偉. You have to elaborate more on that. Number of what? Number of gases product when you compare with that of reactant. One of them is more, right? Okay, reactant. Sorry, I write that already. Is reactant. First of all, it's about the equilibrium. Okay, the product side is less than that of the reactant side, right? It's less. How was less? It's 2 versus 4, right? So increasing pressure, we will shift the equilibrium position to the right. Okay. Increase in pressure, they will shift the equilibrium position to the right-hand side to produce more product. So it will result in high yield. Second is about the rate. How come I increase pressure will increase the rate? How come? By increasing the pressure, I increase what? Yes, I increase concentration, but how come increase concentration will increase the rate? So what will happen to the collision frequency? What happens? Yes, that's right. Collision frequency as well as the number of effective collision increase, okay? Which results in a faster rate. Number, remember, you need to put a number of effective collision. Increase. Based on the given information, suggest one reason why process 4 is considered as a greener process than process 3. Again, a comparison. Process 4, process 3, process 4 is greener process than 3. Why?陳偉豪 again. You have never answered one which is correct.
都係上面嗰個咁樣咯，即係 CO 係要經過一啲嗰啲叫咩啊？
Your friend has circled that with the answer.
哦，即係要答佢 toxic， 唔係，但係上面唔係有另一個答法咩 ？OK，
Now, if you want to, so I would like to hear from your answer as well. Now, first of all, if you want to talk about toxicity of the reactant, it's easy understood, right? Because for the process 4, it doesn't involve any toxic chemical reactants. While for process 3, it involves a toxic CO. So it is a matter of comparison. Okay. How about Chen Weihao? You want to answer from another viewpoint. Okay, what's your point? What's your viewpoint about this? If you want to argue about this, process 4, process 3. Again, sense of comparison. Process 3, you involve the use of toxic as one of the reactant. Okay, so you have got non-toxic reactant to be used. So it is a way to compare, right? Toxic, non-toxic comparison. How about E? Suggest a potential benefit to process 4 to the environment. If you take a look on process 4, how does it bring good to the environment if I use this? This argument has been made before. This point has been made before. What is that? Yes, consume greenhouse gas. So what's the good point of consumption of more greenhouse gas? So what were yes, something about they will lessen the problem about the greenhouse, the global warming. We alleviate the problem of global warming. Okay, you get a point. How about question 3? Question 3. The final 2 questions before the end of the lecture today. Question 3, chloroethene can be produced from ethene by process 5. As this. Again, calculate atom economy. It's easy, right? I do the similar things. You can get the same. You can get the answers very easily. So what is the answer? The step. You are looking for what? Chloroethene. So this is the target substances. Okay, this is the target. While for this part, I should put it here. Okay, times 100%. Now, because this time we have got two here, right, and 1 here, so you are going to put it down correspondingly for the number, because atomic economy is a calculations of the use of atom in the process, right? So you need to put down the stoichiometry as well. So this is 2 times this one ethene. This is 28.0 plus 32.0 for oxygen plus 2 times 36.5 for HCl. So what will be the answer? Is 77.6%. Okay. Give 2 reasons why this reaction is considered as green. Why 2 reasons? Green 2 points. So again, take a look on the equation again. So why is it green? Why is it green? Why? Can you see that? I give you 1 hint. First of all, they will use a European as a catalyst. So what's the good point of using a catalyst? Okay, energy usage will be less, right? Yes, energy usage will be less, while the condition will be less harsh, right? How about take a look at the equation? Can the equation itself imply something about the greenness? Besides taking a look at the reactant, could you please take a look at the product, the byproduct? Yes, non-toxic reactant. Are you sure? Non-toxic reactant, but at the same time you may see HCl being corrosive. Instead of taking a look on the reactant, I will focus on product. Because from the product, you may see H2O. H2O is the byproduct, which is set as non-toxic. Okay, can you get my point? So sometimes you need to get rid of having a debate of another area, right? Once you lead the focus on the reactant, we will focus on the reactant and try to check if your argument is correct or not. So you say that non-toxic, I will easily relate to something which is even not toxic or not, but also poses harm to the environment. So I would easily spot it as HCl, right? HCl is something is no good. Okay. How about C? Give 2 reasons why the manufacture of process of PVC is considered as unfriendly to the environment. Can you see the word manufacturing process of PVC unfriendly in the environment? Manufacturing of PVC. So could you please suggest some reason? The making of PVC, but not the use of PVC. So how can we get PVC? Is from what? Is from VC, right? It's from BC. Now take along the equation. It's not from chlorine. It's from BC, right? Polyvinyl chloride is from BC. BC comes from what? Comes from HCl and ethene. Could you please use these 2 points to elaborate? Could you please use these 2 points to elaborate? How about ethene? Where you will get ethene? It is from, yes, petroleum or crude oil. While petroleum is set as a non-renewable resources. How about HCl? As I said before, I've just mentioned, it's corrosive, it's acidic, okay? So remember, you need to give me the point. Even though you are heading for the feedstock, you need to tell me it is non-renewable. That is the key point, okay? Is that clear? Finally, the final 4 questions. Easy, very, very short answers, and we can end the lesson very soon. Question 4, ethanol can be produced by fermentation of glucose or hydration of ethene. What is the catalyst used? What's the catalyst used in the fermentation of glucose? You use what? You use the enzyme in what? Yeast, right? The yeast, we have got enzyme inside. So what is the feedstock of ethene in nature? I have just mentioned it. It is the 3rd time of telling, right? It is from petroleum. Students think that fermentation of glucose is greener than the hydration, and the ethenes are just one reason. Maybe you think of feedstock of glucose, it is from what? It is some plants which is said to be renewable, for example. Okay? But if you want to talk about hydration of ethene, why do I say so? It's not the product. You focus on the reactant. Why? Because for the reactant, if you say it's renewable, if you have want to have a sense of comparison again, you have to tell the feedstock of ethene. So what is the feedstock of ethene? As said before, from B part, you know that it is from petroleum, which is said to be non-renewable. And other students think that hydration of ethene is greener than the fermentation of glucose. So just one reason, other than the use of catalyst. Can you think? Both they will get ethanol, right? But you will think that hydration of ethene is greener. Can you use one angle to tell? No. How will you get the ethene to form ethanol? It's from what? It's by what? You don't understand? Ethene to form ethanol. So do you know what is the chemical? And do you know the whole process? You don't know? Yes, it's steam reforming. Steam reforming. Not NaOH, it's steam reforming. While steam reforming, I use acid instead. It's not alkali. So acid is a catalyst, right? While these But this process, if you talk about energy usage, of course, hydration of ethene will be more energy consuming. So never touch this part if you want to tell hydration of ethene being greener. Okay. So what else? How about this? Acton economy. You can tell it as 100%. Okay, because I will see the formation of ethanol is the only product, no byproduct. Okay, so which means that you are going to make full use of atoms in the reactant to form the product. So it is 100 atom economy. How about fermentation of glucose? You may get some byproduct. Byproduct of what? CO2. So of course, what is the hidden message? The atom economy is not 100%. Can you get my point? What do you think about this lesson? Would it bring something good memory to all of you, such that you just to remind yourself, it's time to refer to the questions again, okay? In order to get a good marks in your quiz. As said before, Friday quiz. Do you still remember? Friday quiz. First half, this Friday. Second half, it is on what? So what I mean is for the 2 chapters, in this, will we have it next week. So yes, that's right. You have to recite something. You have to recite something before you can score high. The final part will help the markers distinguish which one is qualified to have a 5 star, 5 double star. Okay, while who cannot be deserved to have it. So at least you need to memorize something. Any more questions? No. So I will just stop it here. Next lesson, that is this is Friday. Friday we will have the revision on NChem, and see you this Friday. Bye bye.